Continuation to the previous video. In this video also we are going to find out the neighborhood at real line only. Here in this problem we are asked to find out the neighborhood of 2 with radius 0.25 when the metric is defined in different format. Now let us find one by one. In the first case it is given that d3 of xy is minimum of this thing. First of all we need to find out the neighborhood of 2 with radius 0.5. It is going to consist the collection of points in real line satisfying this condition. What is that? That is minimum of 1 and absolute of x minus y, and here x is 2. So absolute of 2 minus y must be less than what? It has to be less than 0.25. Okay. This we have to collect these kind of points. Now look at here, it is going to be minimum of 1 comma absolute of 2 minus y. This is a fixed quantity. This is not less than 0.25. Hence it must be the case. Okay. When it is the case, absolute of y minus r and collection of y in r such that absolute of 2 minus y is less than 0.25. And when you solve this inequality, you will get what is the neighborhood here. Minus 0.25 less than 2 minus y less than 0.25. It is y in r such that minus 2 less than minus y then 0.25 minus 2, and it is the collection of points in r 2.25 less than minus y less than minus 1.75. When you take the inverse, you will get 1.75 less than y less than 2.25, and is going to be the segment 1.75 comma 2.25. It is the neighborhood of 2 with radius 0.25 under this metric. Okay. Now let us find for this case. Here also we are going to find out the neighborhood of 2 with radius 0.25. It is going to be the collection of points in real line such that absolute of 2 minus y upon 1 plus absolute of 2 minus y is less than 0.25. It is the case, right? Now let us solve this and see what is the neighborhood in this case. Okay. Let me consider only that part in order to reduce the writings. Less than 0.25. So this is absolute of 2 minus y less than this 0.25 can also be written as 1 upon 4 times of, when you bring this denominator to that side, you will have 1 plus absolute of 2 minus y. So this is absolute of 2 minus y minus 1 by 4 times of absolute of 2 minus y less than 1 upon 4. So this is 3 upon 4 times of absolute of 2 minus y less than 1 upon 4. Okay. So this is absolute of 2 minus y less than 1 upon 3. Now we need to solve this inequality, and this is going to be minus 1 upon 3 less than 2 minus y less than 1 upon 3. So minus 1 upon 3 minus 2 less than minus y less than 1 upon 3 minus 2. So this is minus 7 upon 3 less than minus y less than minus 5 upon 3. So when you take the negation, you will have 5 upon 3 less than y less than 7 upon 3, and this tells you what your neighborhood of 2 with radius 0.25 is going to be the segment 5 upon 3 comma 7 upon 3 under this metric. Now we are going to find out the neighborhood under this metric. neighborhood of 2 with this radius is going to be the collection of y in real such that absolute of x cube minus y cube is less than 0.2. Right. So what is x? That is 2 cube. Okay. So this is going to consist the points satisfying minus 0.25 less than 8 minus y cube less than 0.25. Okay. So this is the collection of points such that minus 8.25 less than minus y cube less than minus 7.75, and this is yr such that 7.75 less than y cube less than 8.25. We need y, right? So it is 7.75 power 1 upon 3 less than y less than 8.25 power 1 upon 3. So this is going to be the segment 7.75 to the power 1 upon 3, comma 8.25 to the power 1 upon 3. In the previous lecture and in this lecture, we have found the neighborhood of a point in a real line with different metrics. In all the 5 cases, we get different type of results. Okay, this might have given you the idea that the neighborhood of a point in a same set but with a different metric lead to different kinds of neighborhood. So while finding the neighborhood, the metric plays a very important role in finding that. So we have come to the end of this lecture. If you have any queries, you can post it in the comment box. Thank you.